Hello everyone, my name's Chris and welcome to the channel. Over the last 10 years I found that wireless dimmers can be a quick and easy solution to most of our conundrums, whether it be a table lamp center stage or a fireplace on a tracking wagon. I wanted to make a tutorial series that covered all the questions that I had when I first started using wireless dimming. This video will walk you through the setup, use, and advanced features of the RC4 wireless ecosystem. In addition to this video, there will be shorter clips that will cover specific things, such as addressing, setting IDs, and profiles. These clips are designed to give you a quick and easy access to answers while setting up a project on stage. I want to thank RC4 for their support and sponsorship of these demos. In front of us, we have a selection of RC4 wireless products. If it has a blue label, that means it operates on the 900 MHz frequency. If it has a purple label, it operates on the 2.4 GHz frequency. Here we have the DMX-Pix, which is a wireless pixel driver. We have the DMX2DIMM, which is a 2-channel dimmer. The DMX4DIMM, which is a 4-channel dimmer. The DMX4DIMM 500, which is a high output dimmer. The DMX-IO transceiver that operates on a 2.4 GHz range. And the DMX-IO transceiver that operates on the 900 MHz range. Let's talk about what makes up an RC4 wireless system. You have to have 5 components. First, you have to have a lighting console. Without DMX data, what's the point of having wireless dimmers? Second, you're going to need a transceiver, which will take your DMX data and send it out wirelessly to the dimmers. Third, you're going to need a wireless dimmer, such as this DMX6DIMM. Fourth, you're going to need a load, such as a tungsten lamp or an LED source or even a solenoid. And then the last thing you need is a DC power source, such as a battery or a power supply. In an age of an insane amount of wireless devices, we have to take steps to protect our data. Each RC4 wireless system has a separate set of unique private IDs to keep your data separate from other systems. Each private ID will handle one separate DMX universe. If you need multiple universes in your space, you can use multiple private IDs to allow for multiple wireless systems to operate at one time. For example, I recently designed a production of Into the Woods at the Utah Festival Opera and Musical Theater. The costume designer Mallory Pruka and I decided that we wanted to pixel map the ugly witch's dress to express her emotions and her magical abilities. We also had wireless pixel mapping built into our staff. In total, we needed 3 DMX universes of pixel mapping and another for regular wireless dimming. We used our 3 private IDs for the pixel mapping plus the public ID for the wireless dimming to give us the most flexibility that we needed. This project and pixel mapping will be discussed and covered in another video. You can find the Ugly Witch video in the top corner. We also have a series of in-depth videos on how to set up and use the DMX-Pix units. When you receive an RC4 product, ID 0, ID 1, and ID 2 are your own private IDs. ID 3 is a public ID that is shared among all RC4 Series 2 and 3 products. Now, let's say a designer adds 2 more chandeliers that have to be wireless and you're out of dimmers. You call your friends across the street and ask to borrow theirs. The RC4 devices from their system will not work with your private IDs. That's the whole point of having a private ID. No one else has it. But you can set your equipment and theirs to ID 3, which is the public ID, and everything will connect at that point. Now, you always want to use your own private IDs. ID 0, which is the factory default, is typically okay for most users. For the most part, when you receive your RC4 device, they're ready to go, plug and play. Most of the time, the default settings are ideal, and all you need to do is add power, DMX, and set the address. When you first power up a transceiver in dimmers, it can take up to 10 seconds to create a network. Just a reminder that devices that are intended on being used together must be on the same private ID. When you power up your devices, the currently selected ID will be indicated with a blinking pattern using the DMX data and the COP indicators. The DMX data indicator is yellow, and the COP indicator is green. There are 4 different patterns to indicate the IDs. ID 0 is indicated with a rapid blink of the yellow DMX indicator. ID 1 is represented by a rapid blink of the green COP indicator. ID 2 is represented by the yellow and green indicators blinking at the same time. ID 3 is represented by the yellow and green indicators alternating. You can change IDs at any time by simply holding the set ABC or the set DEF buttons on power up. Once a new ID is captured, its ID blink pattern will appear. As you can see, we've added a switch in line to aid in our demonstration purposes. On power up, you'll see the yellow DMX data indicator flash. That's confirming that we're currently in ID 0, which is the default ID. If we want to change to ID 1, we're going to turn the power off, press down the set DEF button, turn the power back on, and you can see the green COP indicator flash, confirming that we have changed to ID 1. To go back to ID 0, we're going to turn off the power, press down the set ABC button, turn back on the power, and you'll see the yellow DMX data light flash indicating that we are back in ID 0. To select the public ID, which is ID 3, we would have to hold down both the set ABC and the set DEF buttons at the same time. A paper clip will be your best friend in doing this. When you do so, you should see that the yellow data and the green COP indicators flash alternately. On 3-button devices, ID 2 can only be selected with the RC4 Commander software. We will cover the Commander software in another video. Setting the IDs in the DMX I/O transceivers works exactly like we just did in the DMX 6DIMM. After the devices are powered up, the DMX data and the RF Connect indicators will provide you with various information. As expected, when DMX data is present, the yellow DMX data indicator will flash. On the DMX I/O transceivers, when in transmitter mode, the blue RF Connect indicator will blink slowly, showing that wireless connection has been formed. When your DMX 6DIMM is searching for a connection, the RF indicator will remain solid and not blink. Once it has found a connection, it will blink quickly and continuously while your dimmer is connected. As you can see, we're currently blinking, which means that we are connected to our transceiver. A new or restored to default device will be set to a 1-to-1 addressing. DMX address 1 for dimmer A, address 2 for dimmer B, and so forth. With any new setup, before changing any settings, play with the DMX levels for these addresses to make sure your wireless dimmers work as expected. Each dimmer has an LED indicator that is connected directly to the dimmer's outputs. This will show you exactly what each dimmer is doing. We are using an ETC EOS Nomad Max setup for our tutorials. If I bring up address 1 at full, you should see dimmer A's indicator light up. If I bring up address 2, you should see the same thing for dimmer B, and so forth down the line. RC4's OneTouch makes it easy to address a dimmer quickly and on the fly. OneTouch uses the DMX address and its level to set the dimmer's addresses and parameters/dimming curves. To set the most common curves, use the levels listed. For non-dim, set your address at 100%. This is for relays, solenoids, and air valves. If you want linear, set your address at 70%. This is for incandescent lamps, halogens, and tungsten lamps. For an ISL fast, set your address at 50%. This is for when LEDs need to blink quickly and flash. It will disable the RC4 digital persistence. And then for ISL slow, you want to set your address at 30%. This is best for most LED dimming applications, which uses the RC4 digital persistence for super smooth 19-bit dimming. That's also the default setting. On the EOS system, we'll be using the command go to Q out. Don't use go to Q0 command because that only takes intensities out, but it will leave pan and tilt everything else the same. Next, we want to bring up your intended address to the level that selects your desired dimming curve. Since we're connecting LEDs, we will want the address level to be selected at 30% for an ISL slow curve. Let's say we want the LEDs to be addressed at 101 through 106. We'll type into EOS address 101 at 30, enter. Then on the DMX 6DIMM, we'll tap Set ABC. Address 101 will become the DMX 6DIMM starting address. When you set dimmers ABC, all 6 dimmers are automatically set sequentially. Dimmer A will be address 102, dimmer C will be address 103, dimmer D will be address 104, all the way through dimmer F, which will be address 106. If you want dimmers D, E, F to be at starting address 121, you repeat the same steps that we just did, but this time you press Set DEF button. So let's type into EOS 121 at 30, enter. Tap the Set DEF button. Now dimmer D is address 121, dimmer E is 122, and dimmer F is 123. Each set of 3 dimmers, A, B, C, and D, E, F, are always sequential. Remember, set ABC assigns all 6 dimmers sequentially. If you want dimmers D, E, F to be set differently, you have to set ABC first, otherwise setting dimmers ABC will overwrite D, E, F. Now that we're addressed, let's add a load to each dimmer. Always be sure to remove power while making connections. Don't forget, wireless devices can be high current. You will connect the common positive wire to either of the positive output terminals. It doesn't matter which one you connect to, they're both connected internally inside the DMX6DIMM. The 2 positive terminals makes it easy to connect 2 RGB light sources, each with their own positive common wire. The dimming happens on the negative terminals. For a 2 RGB LED system, you would do the following. For the first strip, red would be on A, green would be on B, and blue would be on C. For the second strip, red would be on D, green would be on E, and blue would be on F. If using 2 RGB LED fixtures or devices, connect the first one to dimmers A, B, C, and connect the second one to dimmers D, E, F. Let's take a moment to check to make sure that we wired things correctly. We will be testing a warm white and an RGB LED strip. We are going to first connect the RGB LED strip to dimmers A, B, C. And now we're going to connect the warm white LED strip to dimmer D. Now that we've connected our light sources, let's reconnect the power. We will give the dimmer a moment here to establish a connection with the DMX I/O transceiver. Alright, so let's turn off the studio lights now so we can see what we're doing. We have our first address, which brings up the red. Our second address, which will bring up our green. Our next address, which brings up our blue. And finally, our next address will bring up our warm white LED tape. In another tutorial, we will look at the RC4 Commander software, available for Mac and Windows, which provides a user interface for configuration and working with advanced settings on the multiple RC4 devices remotely. A couple important things to note. The DMX6DIMM should only be used on DC voltage and no higher than 35 volts. Doing otherwise will severely damage the device and is extremely dangerous for the operator. Wireless dimmers are high current devices. For the DMX6DIMM, do not exceed a total of 16 amps shared across all 6 dimmers. Always use a fuse or circuit breaker at the source of power, and always use appropriate wire size for the fuse rating. For example, if using a 15 amp fuse, use wire that can safely carry 15 amps. Dimmers, wireless or not, generate heat while operating. Make sure you allow for space for air to move around the device to keep it cool. Thanks for watching. If you have thoughts or questions, please comment down below. If you found this tutorial helpful, please drop a like and subscribe to the channel to stay up to date with new tutorials as they come out. Below, you can find a link to RC4 Wireless where you can find information about their products and their rentals. Thanks for listening, and happy storytelling.